Hey guys, and welcome back to yet another one of these Maths Made Easy videos. Today we're going to be looking at binomial expansion, and in brackets it says positive integer powers because in A2 we get to learn about fractional powers and negative powers and all that fun stuff that we love. So first things first, what is binomial expansion? Let's quickly discuss all the different ways that I'm going to help you in your GCSE or A-level maths careers. First of all, I wanted to talk to you about the YouTube members. This is a really cost-effective way of getting tutoring. So I'm going to do weekly live streams for GCSE and A-level maths, and that all comes for £18 a month, and you get at minimum an hour of tutoring per week in these live streams. At the moment, they're quite small, so you basically get tuition for about £4.50 an hour, which is really, really cheap. The second thing is the Patreon. For those of you doing A-level maths, I have already completed AS Stats on my Patreon. It is a full course with worksheets, mark schemes, videos. I answer all the questions. We're going to do exam papers and everything that needs doing. We're halfway through mechanics as of yet. And lastly, there's tuition. I still have places in my group classes for A-level maths and GCSE maths. For GCSE it's £30 an hour, and for A-level it's £40 per hour. So if you want to let me know if you're interested, just email me or join the Discord where I'm very, very active all the time. Anyways, back to the video. Why do I care? Well, let me take you through a little story, so to speak. So if I asked you to expand this bracket right here, you'd say, that's nice and easy, it's x plus 1. And then if I asked you to expand something like x plus 1 squared, I'm hoping that you'd be able to get to x squared plus 2x plus 1. Because what you'd have is you'd have two separate brackets that you can then expand and nice and quickly get to the final solution. And then if I asked you to do x plus 1 cubed, well, then you'd probably have to expand it like this, x plus 1, x plus 1, x plus 1, and then you pick two brackets and you do this thing where you expand the first two brackets, which would be x squared plus 2x plus 1, and then you'd still have the x plus 1, so now you have to expand the brackets again, so then you'd have x cubed, plus x squared plus 2x squared plus 2x plus x plus 1, and then you'd close that all up nice and neatly to get x cubed plus 3x squared plus 3x plus 1, right? Well, okay, and then what if I asked you to expand x plus 1 to the power of 4? Well, then you'd probably tell me to, well, I mean, I'm not gonna say what I was about to say, but you'd probably tell me to go and do something, right? Because it just gets unreasonably difficult, and in fact, it gets exponentially difficult because you have to expand more and more and more and more terms. Now, funnily enough, there's actually a pattern between expanding with the power of 1, power of 2, and power of 3. Now, what would make this really easy, if you have a look, if you notice, the power of x just goes down, right? So it goes from x to the 1, x to the 0. Then we have x to the 2, x to the 1, x to the 0. X to the 3, x to the 2, x to the 1, x to the 0. So if we could somehow work out what the coefficients were, we could expand even x to the power of 4 really, really easily. Because all it would be is x to the 4 plus something x cubed plus something x squared plus something x plus a constant 1. Now, if I just work out what the numbers in front are, I would have expanded the bracket in a much quicker way. Now, there is a way to do this, actually. The first way is called Pascal's triangle. And it is the same Pascal who has a unit of pressure named after him. So Pascal's triangle, and this is how it works. So we start off with just 1, like this. This is for n equals 1. In fact, I'm going to move this slightly further away. So this is going to work for x plus 1 to the power of n. It's going to give me the coefficients. If you notice at n equals 1, we get 1 and 1. And if you look, the coefficients of both of these is 1. Then you keep kind of spreading out this, and the middle is going to be these two added together, which gives me 1, 2, 1. And if you have a look at the coefficients for n equals 2, you get 1, 2, 1. Cool, right? So 1, that's going to be 3 now because we add 1 and 2. That's going to be 3, and that's going to be 1. And if we have a look at the coefficients of x cubed, we have 1, 3, 3, 1. Okay, so now to do n equals 4, all we have to do is spread out the 1 again, and we get 4, 6, 4, 1. So then if I go over here, my answer will be, well, there's a 1 in front of the x to the 4, so don't write anything. Then we have 4, 6, 4, 1. How cool is that? Expanded a bracket really, really quickly. Okay, but then what if I had something like x plus 1 to the power of 10? Could you see writing out all these numbers all the way to n equals 10 is going to make me want to die? It's too tricky. Or at least it's too long, right? It's not tricky. Adding numbers is nice and easy for us, but it's going to take us a really long time. So is there yet another way? The answer is yes. If you pull out your calculator, ta-da, I want to expand this a little bit just to make it a bit easier for you to see. You have a very special button called the NCR button. Hopefully you can see that. So it literally has the letters N, C, and R there. And we get there by pressing the Shift key and the divide symbol. Now, if you have a different calculator, then of course it's going to be different. I know, shocking. So I'm going to just quickly write down NCR. N is simply the power of the bracket. And R is, I like to call it, it's the position that you're in. Now, if any of you do programming or know anything about programming, position will make a bit more sense. It's like an array or a string. And we start counting from 0. I know, weird. But you will get used to it extremely quickly, which is good. So for example, if I want to generate the first coefficient in an n equals 4 expansion, I would simply put 4 here, and I'd put 0 on the end, and it would give me 1. If I change that to a 1 now, I get 4. If I change that to a 2, for the third value, I get 6. So can you see I'm generating them all on a calculator, nice and easy. Perfect. This is what we're going to use to expand brackets of any size. Really bloody useful. Now, let me show you how to do this with a question. Now, of course, we don't always just have x plus 1. We may have 2 plus x over 2 squared, or 2x over 2, sorry. Something along those lines. So let me show you how this works. First thing it says is find the first 3 terms in ascending powers of x. Okay, so what I want you to do now, first thing first, is we're just going to write the coefficients down. So what is our power? Our power is 6. So I'm going to change the 4 to a 6, and we're looking at the first coefficient, 0. And if you notice from Pascal's triangle, it's always going to be 1, and the last one's also going to be 1. But, you know, in for a penny, in for a pound, might as well do it. 1. Then I'm going to leave a bunch of space, and I'm going to put the next coefficient. 1 gives me 6. Cool. Plus 6. Big space. You don't even need to leave that much space, but I like to. And if you notice, it says the first 3 terms. So that's the good thing about this, is we don't have to generate all of them. It will normally be the first 3 terms, sometimes 4, but usually it's 3 terms in exam questions. Nice and easy. And then 2, we can just do that, and then boom, we get 15. That's the first step. Now, this is the really important part, ascending powers of x. So you know how I said usually it's the first 3 terms? I mean, almost always it's the first 3 terms. It's also always ascending powers of x, which is really, really, really nice. So what that means is you're starting actually from, you're going backwards. Now that might sound more tricky, but it's not, because I'm going to show you what happens. Do you remember how I said the power of the x term goes down, right? So it goes from x squared, x, and then x to the 0. Here it goes x to the 4, x cubed, x squared, x1, x0. Okay? So if we're going in ascending powers, we're going backwards. So it'd be x to the 0 first. Okay? So this x term, which is x over 2, goes like that. Now, something that we didn't spot because we had x plus 1 is that this plus 1 term actually increases in power as we go along. So in this case, we start with the highest value of x and we start with the lowest value of the constant term. And then as we reduce the power by 1, we increase the power of the constant by 1. So since we're going backwards, as I said, we're going to be, over time, increasing the constant, increasing the power of the x term, decrease the power of the constant. So what's the biggest power of the constant? In this case, it's 2 to the power of 6. Now that might seem a bit confusing, but watch what happens. We reduce the power by 1 and increase this power by 1. Reduce this power by 1, increase this power by 1. Because that's how it works when you expand brackets. However, when we expand brackets, we normally decrease the power of x by 1, increase the power of this by 1. However, with binomial expansion, because we're going into ascending powers of x, we're going to increase the power. We're going to read it backwards. Increase the power of x over time, decrease the power of the number, the constant, over time. That's it, 4 marks. All we have to do now is simplify it. So easy. X over 2 to the power of 0 is going to be 1. So literally all we're doing is we're doing 1 times 2 to the power of 6. So we have 64 as the first term. Now what would I do for the next one? Well, all we have to do is change the coefficient, change this power to 5. Now, of course, we actually still have 1 over 2, right? Don't write x on the calculator because it won't know what you're talking about. So it's 96x. And again, all we're doing is we're changing the constant at the front, reducing the power of 2 by 1, increasing the power of the half by 1. And then that's going to be 60x squared. That is 4 marks. 4 marks. 2 lines of working out, and I did it all on a calculator. So what are the problems? Why is it worth 4 marks? Well, A, people tend to forget to reduce or increase the power. In fact, a lot of students actually skip this first bit here. They ignore it. So then they don't put the 1, which means that they can screw up the later parts. Other reasons is because people don't take it slowly. They've given you 4 marks, so it's roughly 4 minutes. Use that time. Take it slowly. Work through it. You have a lot of time. So, it then says, use your expansion to find an estimate for the value of 2.05 to the power of 6. So how do we do that? Well, it's quite simple. This binomial expansion that we've got here looks like this. And it's an approximation, so the wiggly equal signs means that it's a approximation. It's shaky, you know, it's roughly. Like this. And we want to find an approximation for 2.05 to the power of 6. If you notice, the power is the same, right? So in other words, what's inside this bracket should equal 2.05. So the first thing I do is I minus 2 from both sides. We get x over 2 equals 0.05. Times both sides by 2, we get x is equal to 0.1. So in other words, all they want me to do is substitute in 0.1 in for x. But you need to show that you've worked out x. Okay? So that will give me 2.05 to the power of 6 being approximately 64 plus 96, 0.1 plus 60. And by the way, this is actually what binomial expansion is used for in real life, is approximations, because certain calculations are too long for computers to do, so we approximate instead. Because if you look, or if you notice, if you're a bit math savvy, the actual value of each term is decreasing, right? Because here it's 0.1, so we're dividing that by 10. Then we're dividing this by 100, so the numbers are going to get smaller and smaller and smaller. And we get 74.2. So what I like to do sometimes to have fun, because I'm a loser, is I like to just do 2.05 to the power of 6 and see what happens. Not bad, 74.22. Not bad at all. Hopefully that makes a lick of sense. And we'll move on to the next one. Now, of course, there are always different types of questions that we're going to do, so I'm going to give you an overview of every question that we can do. Part A, very similar. So what I would like you to do right now is pause the video and have a go yourself at doing this. Again, with maths, it's a very active subject. You need to practice yourself. So I'm going to assume that you've done that. You better have. But all we're going to be doing is, once again, using the NCR button on our calculator to work out the coefficients first. So whip out the calculator. We want Shift NCR button. What is the power? The power is 7. Start off with 0, and we know it's going to be 1. So 1, leave a gap, plus. And what does it say? The first 3 terms again. So we're only going to go up to 2. 7 and plus 21. Like so. Now what do? We start off with the highest power of the constant and the lowest power of the x. So we have 2 to the power of 7. And then we have minus x over 8. So it is a negative, so we need to make sure we keep that negative. And then we keep going. So reduce the power of the constant by 1, increase the power of x by 1. Very formulaic, but you may have made a couple mistakes in your working. That is completely fine. It happens. As you practice, you will make fewer and fewer mistakes, I guarantee you. So, let's work it out. Well, of course, the first one is just going to be 2 to the power of 7. Technically, it's times by 1, but, you know, it's not though, is it? So, 128. Then, I'm not going to put it as plus because I can see it's probably going to be a minus. So, we have 7, open bracket, 2, power of 6, and then we have minus 1 over 8. Again, we don't bother writing the x. We get negative 56x. And then the next one should be a positive. Again, if you're not sure, you can always work it out first. And so let's change that to a squared. Let's change the 6 to a 5. And let's change the 7 to a 21. And we get 10.5x squared. Like so. And again, 4 bloody marks. It's all on a calculator. But part B looks a bit scarier. And honestly, it sounds a bit scary. So we have f of x is equal to this times this, where a and b are constants. Given that the first two terms in ascending power of x are this and this, find a and b. So what they're trying to tell me is if we were to expand this truly gargantuan bracket here, we'll get two terms. The first two terms in ascending power of x is 384 and negative 104x. Well, we've actually already kind of got the first two terms. All we need to do is times it by x plus b. So this is not an approximation in this case, because we're only looking at the first terms in ascending powers of x anyway. So now I'm going to use now we have to expand this. Now, if you use your noggin a little bit, you realise you don't have to actually expand that much. So why is that? Well, we're looking at the first two terms in ascending power of x. In other words, we're looking for the x to the 0 term and the x terms. So when I multiply out this bracket, anything that gives me x squared or x cubed, I can ignore. So let's have a look at this. ax times 128 is completely legit. So 128 ax. But I can't do ax times 56x because that give me x squared, and I can't do ax times 10.5x squared because it give me x cubed. It's too big. I'm only looking at the first two terms. So let's go to b. Well, 128 times b, that's completely legit too. And b times 56, negative 56bx, is also correct. So now let's put this in like order ascending powers of x, because again it tells me in ascending powers of x. So we start with the 128b. Then we have 128 ax minus 56 bx. So these are my first two terms. We have 128b as my first term, and all of this is my second term. And it tells me what they're equal to. So 128b, the first term, should be equal to 384. Divide both sides by 128. I'm going to pray that this isn't an ugly number. 128. Actually, I think it goes in 3 times. Perfect. So now I know that b is 3. And then it tells me that the x term, the second term, should equal negative 104x. So in other words, we have 128 ax minus 56bx, but b is 3, don't forget, equals negative 104x. So what's my first move here? Well, the first thing I'm going to do is I'm going to divide everything by x. So in other words, I'm going to delete all of the x's. That will give me 128A minus 56 times 3. Let's work that out. So 56 multiplied by 3 gives me 168. Equals negative 104. Add 168 to both sides. Gives me 64. So then A is equal to 64 divided by 128, which is a half. So A is a half, and B is equal to 3. Not that bad, really. It looks like it would be bad, but it's not that bad. By the way, this is practically guaranteed to come up in your Year 12 mocks. So just keep that in mind. 8 marks. Huge. Huge. About what, 10% of paper of the paper you're doing Year 12? So overall, 5% of your grade just on this. Not bad. Increase your grade by 5%. That's not bad at all. That's quite close to a grade boundary. Here we go. Now here's where things get interesting. So with A-level maths, they really like to do something called symbiotic maths. So that sounds really fancy, and it's not about like Venom or anything. What it is it's using different parts of maths in other parts of maths. So this right here is actually a statistics question. I know, right? So they've taken statistics, put it in pure maths with regards to this. So this bit here is fully expand. I know it kind of sucks, right? It kind of sucks. But since we're fully expanding, it doesn't matter the order. But the first thing we need to do is, once again, get our good old-fashioned NCR button and work out all of the coefficients. This will not take too long, I promise. The power is 5. We're going to start with 0 and we're going to end with 5, right? So we have 1, and then plus 5, yeah. So again, it doesn't actually take that long because there's only going to be 5 terms, well, 6 terms in total. Doops. And again, since we don't actually have any numbers, it's literally just going to be like p to the 5, p4q1, p3q2. Like, it's not actually that bad once you get used to it. 5, and then I know that the next one's going to be 1. And if you notice, it is symmetrical when you have an odd number. It can't be symmetrical when you have an even number, of course, but when you have an odd number, it's always symmetrical, which is nice. And then again, like I just said, it doesn't matter if you start with P or Q, to be honest, because it's fully expanding. But it's going to be P to the 5Q0, P to the 4Q1, P to the 3Q squared, P to the 2Q cubed, Q cubed, interesting, P Q4, and then Q to the 4. So if we simplify this, we literally just have P to the 5 plus 5 P to the 4 Q plus 10 P cubed Q squared. God, I hate saying that. 10 P squared Q cubed plus 5 P Q4 plus Q to the 5. I forgot to actually increase the power. Thank God I spotted that. There we are. Oh, there we are. Not too bad. Slightly more annoying, but we should keep in mind that it is technically easier to an extent. But now here's where things get spicy. So we've got 4 marks. We've already got most of the marks in the question, and we haven't even done the hard bit. In my opinion, the hard bit. It then says, let the probability of Dave being late on any school day is 0.1. So P is equal to 0.1, right? So then Q would have to equal 0.9. And it tells you, use the last 2 terms of the expansion, so these two. Yeah? Find the probability that Dave is late no more than 1 time in a school week. Well, if you notice, the probability of him being late once is going to be, he's late once, and then he's on time, on time, on time, on time. So if you notice, that actually gives us the answer. And the other probability, the other outcome, is that he's never late. So he's either never late or he's late once. We're not including he's late twice, 3 times, or 4 times, because it says no more than 1 time. So it's just these 2 terms here. And all we need to do is literally sub in the probabilities that they've given us. And that's 3 marks, by the way. 3 marks for doing a simple substitution on your calculator. But again, it's the conceptual knowledge, knowing to do that, which is, it's obviously very tricky. And it's brand new as well, right? Like, you're not really expected to do stuff like this in GCSE. So the fact that we have to do it now is scary. But it's not that bad, and I'm going to get you through it, okay? Just practice, learn, and if you are ever unsure about what I'm doing or why I'm doing something, then let me know, leave me a comment, and I can help you out. I can explain it again. So that right there was the binomial expansion in a nutshell. So I've gone through a few different exam questions that can turn up in your year 12 papers. So all you need to do now is go and practice it. It's very similar every single time. It's not that bad, and I know that you're going to get it. But anyways, I'm going to leave you to have a wonderful day, and I'll see you in the next one.